So I took the next step in my neural network research. I just got into the stock market stuff, but I didn't want to just gamble. So I thought I'm going to try to apply neural networks to the stock market. I found a lot of people that were trying to do this, and everything I found, some I had to get into it a lot, some you could see right away, but nothing worked, or they don't do it in a way that it's profitable. And it makes sense. Like if something that's online, you could just take it and make money on the stock market, that would be a little too easy. I tried to learn another kind of neural networks, and I experimented with multiple kinds. But in the end, especially since I saw that those methods didn't work, I wanted to try something different and that I could understand better. So I took the idea from image processing, and I thought, what if instead of pixels, we just have as features? So you have 30 days of 10 companies, and then as a result, you get the 31 day of whatever company you're trying to predict. Then every sample of these will just be the same data, but shifted one day to the future or to the past or whatever. So you have monthly changes in the stock market in 10 companies. And with that, my idea was that maybe there's some correlation between those, and maybe you can predict one of the companies, seeing how the others behave. So I imported the data using Alpha Vintage. There's a Python library that's very useful. You can make 500 calls a day. So this program makes 10 calls. They get all of this data from 10 different companies, 20 years of data. And then I process it. I change the format of this data to be compatible with my neural network. I create two vectors, the one with the samples and the one with the results. I split them in training and test, as always, and then I run the neural network. Very simple in TensorFlow. I think I had like, I don't know, like maybe 1,000 lines of code in the C++ neural network that I did from zero. In here, you literally have 10 lines that do everything when it comes to the neural network. But I mean, it's good to know exactly what's going on. I changed a line here because this was set specifically for images dimensions, and I wanted to take samples just vector and vector and vector instead of a matrix of an image. So I changed the first layer, but it's not really that. I even tested it with the images to make sure that it didn't change much, and it doesn't. It works anyway. What I did, this is important, I just divided the estimations. Like for example, if it's a decimal point, the change in the stock market, if it's just a decimal point, then that's one classification. If it's around 10 values, around 100, there's different levels of increase or decrease in the stock market. So I classified it like that. So what it's trying to predict is the changes in the company stock overall, not specifically. That would be a great help if we know when it's decreasing and increasing, just that. There's three kinds of results. Minimal change, which is between -1 and 1, something very slightly, and then positive change and negative change. The accuracy in the training, which is the one with more data, it's usually above 50%, like just a little above 50%, which is fucking cool. It basically means that something like you could have a 1% profit in 20 years of data, or 2%, which of course is not viable to make money. But the fact that it's going above 50%, that's really cool. Maybe with different kind of data, maybe if I had more insight into how things work when you're a broker, when you actually invest in this stuff. Because right now all I'm trying to do is I'm taking the data, raw data, I'm running it through the machine, and the machine is trying to see some pattern, to see some logic to these numbers. Either because my theory that these companies are correlated is not correct, or because there's not enough data, like maybe it's just extremely random and there's no pattern. I do believe there's a pattern, otherwise I know there's people that make money with this, so there's gotta be some kind of pattern. But you gotta find the right data. You gotta approach the data and find the right data in the proper way, so that the machine has an easier time. That's it. This was fun. This was a good learning experience. It wasn't a success because it was extremely ambitious, but it was a success in a smaller scale.